Morning, guys. Mr. Catlin here. We're looking at your second day of NTI, and um, for your viewing pleasure, I don't know, not much of a viewing pleasure, but I've added the webcam today, so you get to check out my mean mug for a little while if you watch the video. And hi, hope you guys are doing all right from home. And we're going to go through some of these problems. I will say before we start, I've had a few people that have worked ahead point out some incorrect questions on future days. So I've noticed those too, as you've pointed those out. So as I make these videos, I'll try to point out like which ones are wrong, and maybe try to steer some people that haven't done them yet in the right direction. So keep an eye out for that. But I think I just looked over today's. It looks like all the questions are solid on this one. It looks like more of the problems come in the latter days, like 8, 9, 10, somewhere in there. So let's jump right in with the first problem here. We're going way back to proportional relationships and looking at graphs to start off this particular lesson. And the key thing that you need to remember about the graphs is they have to be straight. They got to be a straight line, and they have to go through the origin. So if you look at the first one here that they're showing you, you'll notice if you look right here, right here. Well, I guess it'll be right here. It doesn't go through the origin, so it's going through like it looks like where y is 1. So that doesn't go through the origin, so that means it's not proportional. Make sure that you pick that one there, and then if you continue to the next problem, number 2, it has a straight line. It looks good. So hey, this might be a proportional relationship. But if you look a little bit closer, you'll notice the origin is down here in the very bottom left-hand corner of the graph. So that means that we're not going through that point, and that's bad for proportionality. So this one's another non-proportional for that second slide. Um, and then it just kind of keeps going on. Why does this graph show a non-proportional? So they're already admitting to you that this one's not proportional, and you got to give a reason why. So we've talked about that one on the first two, and you just got to put it into words. And the reason why this one's not proportional, it's not because it's not straight. It's clearly a straight line. The red line is, but the origin of this graph is way down here in the bottom left-hand corner. So it's not going through that point. It's not going through the origin. That's what you should select for that one. So first three, I mean, you really just jump in, and it's really fast. Even the fourth one, you got to look at all 4 of these graphs, and you're thinking, okay, which one of these are straight lines that go through the origin? And you look at them, you're like, okay, it's straight, straight, straight. They're all straight. And then if you zoom in on it, I'm not going to be able to do that. You can zoom in on it, you'll see that they all go through the point of the origin. So that one right there should be all of them. All of them are proportional. So you want to pick the 4th option there. So after that particular one, you get into some review of a couple from yesterday. You guys are lucky that I did not assign these problems. I probably wouldn't have found such bunny questions. But you can be thankful that Miss Followell found this set of NTI work. So these are pretty simple, essentially the same exact problem from yesterday, but it phrased in maybe a different way. Just wants to know if the table is proportional. And this particular one looks like the constant is a quarter, or multiplied by 1/4, and every number below is a quarter of the size of the one number on top. So that is a proportional relationship. That is the blue option there. And then on number 6 here, another repeat question. You could find the constant of proportionality. I think the constant here was like 2.75, or some of you noticed the pattern up and down. So I'm not going to bore you with that one again. If you remember from yesterday, the question was, the answer was 44, and it's the same. It hasn't changed. It's not a different question. Number 7, we look at another table, and this one I know was on there yesterday too. So the constant to get you from hours to money was 9. One thing I don't like about this question is that they're making the constant of proportionality into a unit of money when technically it's money per hour. But I'm not going to get particular about it. I didn't choose the question. So This one would be 9 because every hour is getting multiplied by 9 to find the money. And then you've got number 8, and on number 8, it's just straight up solving a proportion. I guess we can talk about this one for a second. Two different ways um, to approach solving something like this. I'm going to use this beautiful blue color. If you are thinking about what do I do to this number to get over here, you can think, all right, they're just simply dividing by 3. And so if I divide the top number by 3, it should find that. So you can think of it that way. You could also think, what are they doing to the 3 to get to the 12? Hey, there's my son. He's crying. We know, and that happens a lot with 8-month-olds. Multiply by 4 to get down this way, and 3 times 4 is 12, and that's what times 3 would give me, or what times 4 would give me 4. That'd be 1. So another way to find that there. You could also cross multiply and divide. You could do 3 times 4 is 12, and then divide by 12 is 1. So either way, you're looking at having an answer of 1 there. Pretty easy stuff. That's not even 7th grade level, but good thing to review. Let's look on to the next problem. You could actually run into some issues here. So let's set up a little table for this one. All right, so here's my table. We've got ounces on one side, it looks like, and we've got pieces, as I'm going to abbreviate that way. On the other side, it says 6-ounce package will contain 45 pieces. So how many pieces would you expect in a 10-ounce package? So the question mark would go there. And we're looking for the constant of proportionality. What will get me over to the 45? So you could do something like 45 divided by 6, and that would tell you what your constant is, which in this case is 7.5. So we're going to be multiplying by 7.5 to get to the other side. And 10 times 7.5 is 75. Be careful here. This one was trying to throw a little curveball at you. They knew that you were going to find the answer pretty easily of 75. But remember, it's asking how many pieces you would expect in the package, not how much the package weighs. We already know the package weighs 10 ounces. It's not gonna have 75 ounces in it if it only weighs 10 or 8. So make sure you pick the blue one on this one, not the red over here, the ounces. Okay, so 75 ounces for that one. And let's move on to the last question and finish up today's video. Jeff ran 6 miles in 4 hours. At this rate, how many miles will he run in 6 hours? So you could do this problem very similarly to the last one. You could make yourself a little. Let me see. Let me go with that. Oh, come on. Let me draw. Let me draw. What's wrong with you? It's not letting me draw. This is why I like new things. This is why I can't have new things. I break them or they don't work. It just worked like 2 seconds ago. And now it's like, you know what? No, I don't want you to work anymore. Lovely. Oh, that's probably why. Let's see if we can let's clear that one off. See if it'll let me clear that. Erase. Take away. I don't want to have the tools. Highlighter clicks? I don't even know what that means. It's not letting me draw anymore. How unfortunate. Okay, I guess I'll just talk you through this last one. Um, if you can run 6 miles in 4 hours, then how many miles will you run in 6? Well, first of all, you need to divide 6 and 4 to find out what your constant of proportionality is. So if you divide 6 by 4, you'll see that your constant is 1.5. So you can multiply the hours times 1.5 and it will tell you the miles. And in this new situation, you get 6 hours. So you just got to take your 1.5 and multiply it by 6, and it will tell you how many miles we'll run, which is 9. I wish I could have drawn that for you. I guess I could do that on here. Here, let's do this. We got nothing but time. Okay, so if this is, you got miles over here, and you got hours over here. And the original problem said, let me go find it, 6 miles in 4 hours. So 6 miles in 4 hours. And so whenever I divided those and found the 1.5, that was me finding the constant of proportionality. And then it comes along and it says, oh, okay, 6 hours. What if they go for 6 hours? Boom. So your 6 hours is there. You know what to do with it to get over to the miles. I just did 6 times 1.5. And that's how we found the answer of 9 miles. So a visual for you if you were needing that. And that would be the blue answer there. And that finishes up your NTI work for today. Like I say, guys, pretty easy stuff these first couple of days. I think the next few will start to get a little bit more challenging, and I will continue to post these videos to help you if you get stuck. They will just be one long video. I'm not going to break it up question by question like I've done in the past. But you've got time to sit through there and find the one that you need help on. You could just kind of scroll across and look for the number that you need help on. If you look for this, I'll try to do it in this method, or I might mix it up. I don't know. It's a long 2 weeks. I'm going to try to keep some variety in my life, but that's how I'm rolling. Hey Denise, bring him in here. You guys see my the one that was crying earlier, so you know who to blame. He's pretty cute, and his name is Declan. He was born the night that I was supposed to meet most of you guys. Um, but here he is. He's chewing on his hand. Come and bring him over here. I'm making a video for my kids. I thought they might want to see the cute guy, the little fella. Come here, buddy. Hey. Oh, look at the screen. You see that there? Yeah. This is Declan. Say hey, buddy. Say hey. Yeah. I'm showing him how to do some math. What do you think? Ain't gonna be any good. Oh yeah, bounce, bounce. All right. Well, this is Mr. Catlin signing off. I just wanted to share with you guys a little help for today if you needed it. And me and Declan are saying bye. So see ya. Have a good day. Stay well. Don't get sick. Don't catch a virus or anything. Love you guys. Bye.